Good afternoon. We are watching the solution for problem 6.6, which was one of the homework problems. I've got it drawn up on the board. The problem statement is to calculate the forces for each of the pieces of the truss, AB, AC, and BC, and determine whether they're in tension or compression. We'll start by looking at the equilibrium overall. Summation of the force in the x direction, looking at the reactions to support at A, which was a smooth pin, roller at point C. There's only one force in the x direction at AX, which is equal to 0. Summation of forces in the y direction. There are 3 forces in the y direction, AY plus CY minus 18 kilonewtons is equal to 0. One equation, 2 unknowns. We have to go and take a moment. Looking at taking the moment about point A, that means AX and AY would not be players. CY is a player times 9 meters plus the 18 kilonewton external force, which is 13.5 meters. Taking a look at the directions, if the moment is taken about point A, the rotation is about point A. CY provides a counterclockwise rotation, which would be in the positive direction, and the 18 kilonewton one would be in the negative direction. It's a clockwise. Performing the indicated arithmetic, CY times 9 meters plus negative 243 kilonewton meters is equal to 0. Add 243 kilonewtons to both sides. And divide by sides by 9 meters. We get that the force at CY is 27 kilonewtons. And then that allows us to go ahead and take care of back into summation of force in the y direction. AY plus 27 kilonewtons minus 18 kilonewtons equal to 0. AY plus 9 kilonewtons equal to 0. Subtract 9 kilonewtons from both sides. We'll get the AY is equal to negative 9 kilonewtons. Remember, the negative just indicates that I have the direction of CY or the direction of AY in the incorrect direction. I'll go ahead and fix that now. So AY should have been down. I'll move it over a little bit so we can see it. And I'll go ahead and fill in my values. So AX was 0, AY was 9 kilonewtons down, CY is 27 kilonewtons up. All right, give me a second to erase the board. I'll be right back. All right, I went ahead and erased the board and then drew the free body diagram for point A. Point A, so we've got 3 things going on at point A. We've got the 9 kilonewton force going down. We've got a force in AC. We've got a force in member AB. AB is at a diagonal, so we're going to need to know the angle. So I've got a triangle set up here to do that. The 15 meters comes from here. The 13.5 meters, remember we're looking at, to use the trig functions, we need a right angle. The 9 millimeters, it doesn't form, doesn't help us with the right angle to B. 13.5 does, however. So we're using the 13.5 there. So arctan of 15 over 13.5 equals theta, and that gives us an angle of 48.01 degrees. So quickly kind of drawing this out. This is AB again. That's 48.01 degrees. That means that the adjacent is AB cosine 48.01 degrees. opposite AB times sine 48.01 degrees. We can use our equilibrium equations now. Looking at summation of the forces in the y direction, we have -9 kilonewtons. So if I have AB going that way, that means y would be going down and x would be going from right to left. So I'd get negative AB sine 48.01. You probably see that I have guessed wrong. That's right. Add 9 kilonewtons to both sides. I'm sorry, add AB sine 48.01 to both sides. So we get -9 kilonewtons is equal to AB sine 48.01. Divide both sides by sine 48.01, and we get that AB is equal to negative 12.1088 kilonewtons. The negative is the indication that I have it in the incorrect direction. So we'll grab that real quick. So it should have been this way. Okay, that's good to know. Finishing up. Summation of the forces in the x direction. We get, so in the x direction, we get AC. Since I've made the correction up here, since this is really going up, that means that the x has to go from left to right and the y has to go the other direction. So we'll use that new configuration down here. AC plus 12.1088 cosine 48.01 is equal to 0. That gives us that AC is equal to -8.1008 kilonewtons, which is an indication that I have KC in the wrong direction as well. All right, so that gives me AB is 12.1088 kilonewtons, and that's in tension. It's pulling away from the point in a reaction to the fact that it's pulling away from the point is a reaction to the member being in tension. AC, I have now going into the point, which would be a reaction to the member being in compression. Oops. Kilonewtons compression. I'm gonna pause the video right now so I can get the board set up for finding our last members internal of BC. All right, welcome back. Got the free body diagram drawn for point C. That's or joint C. That's the joint I'm going to use to find our last unknown, which is the force internal to BC. AC we know. AC was in compression. So since the member is in compression, the reaction at the joint at joint C would be going into the pin. CY we calculated earlier. I'm just assuming BC is going to be in compression. I may or may not be right. We're about to find out though. BC is at angle, so we need to pick up what that angle is, which so let's see, look like that. So that's BC, that's 15 meters. And this one here is 4.5 meters. So the distance, the perpendicular distance from point C to point B would be 13.5 minus 9. So that's where the 4.5 comes. Take the inverse tan of 15 over 4.5, and we get 73.3008 degrees. Now we need the forces. So we need the x and the y components of BC. So BC, this is going to be BC cosine 73.3 degrees, BC sine 73.3 degrees. Let's see, what do we have? Let's just take summation of forces about in the y direction. So 27 kilonewtons minus BC sine 73.3 degrees is equal to 0. Add BC sine 73.3 degrees to both sides. So 27 kilonewtons is equal to BC times sine 73.3 degrees. Divide both sides by sine 73.3 degrees, and we get that BC is equal to 28.19 kilonewtons. That's positive, indicates that I have guessed the correct direction, which means that member BC is 28.19 kilonewtons in compression. Hope this helps out. See you guys in a little while.